Hi, so I wanted to make a sample video so you knew what I was capable of doing and what technology I had. So this is being recorded on an iPad Pro using an app called Doceri, which I also use in my classroom. Uh, I googled EOC geometry and I found a cute problem. What is the sum of the measures of the interior angles of a 14 gon? I thought it was pretty rich and could lead to a lot of interesting class discussion, so I decided to pick that one for this video. With questions like this, a lot of times my students will ask, what's the formula? And if you're like me, you're very cautious to give out that information without a lot of explanation, because a little bit of knowledge, like a formula, can cause a lot of problems because they start to apply it incorrectly and stuff like that. So we are going to derive the answer from almost first principles. We're going to take a few shortcuts though. So we're not going to give them the formula directly, and I'm going to ignore, for the purposes of this, the multiple choice options. Both of these would be really helpful when it comes to the time right before the standardized test, but for right now, we're not there yet. So the first thing I'm going to assume is that this is a good question, meaning there is one answer for all 14-sided polygons. That allows us to get rid of thinking about any ugly polygons, and we'll talk about that in a little bit. But for right now, we're going to assume that it's a well-formed question. And that allows us to look at this with just a regular polygon, which makes this a lot simpler. Because we can break this up into these isosceles triangles, pretend that that's an isosceles triangle for the purposes of this discussion. We can just think about one of these little wedges. And that makes it easier because we know that a circle is 360 degrees, so the interior angle of this wedge has to be the 360 degrees divided by 14. So that is the inside angle. So if we just look at this triangle with one angle of 360 over 14 degrees, the other two angles, A plus B, when you add those together and add our third angle that we already know the value for, we know that that has to sum up to 180 degrees because this is the angle measure for a triangle, and we have a triangle. So that means if we solve for A plus B, we get that it equals 180 degrees minus this 360 over 14. Now we could simplify this, but there's not really a lot of value in that, in my opinion, and it just leads to rounding errors, so let's ignore that. We could also isolate for A or B, but that's really not helpful, because if we think about this again in terms of these wedges, and we have the same wedge all the way around this circle, then we have our angles A and B being repeated everywhere, which means if we look at one interior angle of the polygon, that interior angle is actually A plus B. So that's the value we're looking for, and it's going to appear 14 different times. So that A plus B is, like we found before, 180 minus 360 over 14. And so that means that we have 180 over 360 over 180 minus 360 over 14, 180 minus 360 over 14, 180 minus 360 over 14. I'm sure you're wondering how many times I'm going to write this out. I'll be honest, I just copy and pasted, and I didn't even do that all the way around. But this angle is being repeated. So if we want to find the sum of all these interior angles, because we're assuming that we have a regular polygon, we can just add all of these up, and it happens 14 times, so we get this 180 minus 360 over 14, and then we just multiply that by 14. And now, finally, you can throw that in your calculator, and we'll get 2,160 degrees. Excuse me if the sound quality just jumped a great deal. I'm now on my desktop, and I opened a website called Desmos, and I've made a rendering of a 14 gon, and you can see that I tell you what the sum of the interior angles are, and I list the angle measure at different vertices, and you can toggle which vertex you're seeing the angle measure of just by scrolling the p-value. The choice of variable is irrelevant. And you can see that I can also drag these points around, and you can see here that as I do that, the 2160 stays constant up to a point, but eventually when I shift, things start to change. Now, I'm sure most of you are geometry teachers, so you know that that's a problem with my program, not with the math involved. But I use sorts of things like this for students that are interested in learning how to troubleshoot and things like that. And some people told me that your school is interested in getting the girls into coding. So troubleshooting is the biggest part of coding things. It's the most painful, it's the most important. So topics like this, you know, is it the program that's wrong or is the math wrong? And if it's the program that's wrong, what is happening? In this case, you can see if I shift the angle measure being shown to this vertex, you can see that it's fine here. This angle measure corresponds to the interior angle, but if I move it inside instead, so now this is no longer a convex polygon, now the angle measure is incorrect. The angle measure should be greater than 180 degrees, but it's actually less than 180 degrees. It's the interior angle for the triangle that these 3 points make, and that's incorrect, and the problem appears when it's not a convex polygon.